this is an acutely paradoxical, puzzling, conceptually confusing theory. On the other hand, we have no option along the lines of throwing it out or neglecting it, because it is the most powerful, proven tool for predicting the behaviors of physical systems that we have ever had in our hands.
The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity. However, when we get down to a small scale, when we get down to, say, the level of atoms, a different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because in the quantum world, everything is in superposition of multiple possibilities, and in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place.
Quantum mechanics is really the play and display of information, the play and display of potentiality, waves of information, waves of potential electron. And it's important, the word potential. This isn't the world of electrons, it's the world of potential electrons. But when you have to ask the question, waves of what, really? What is the field that is waving? Is it the ocean? No, it's a universal ocean. An ocean of pure potentiality, an ocean of abstract potential existence. We call it the unified field, or superstring field. And that's what we're made of.
Connectivity among all things is a basic constituent of the fabric of reality. It's very difficult to wrap your mind around that. But Erwin Schrödinger said, he's one of the founders of quantum mechanics, that entanglement, which is this idea of this connectivity, is not just a property of quantum mechanics, it's the property. It's the property of quantum mechanics that makes it very, very strange. And it doesn't seem to fit in with our ordinary world, our ordinary experience, but in fact, it actually does.
Want to shoot some hoops? No, you don't have to be like that. Come on and play. Look, he likes you. Don't you have time for a little one-on-one? How long has it been since you played? Come on, you got the ball. Take a shot. No, my lady, not from there. It's out of bounds. Gotta be on the court to be in play. Welcome to Duke Reginald's court of unending possibilities. Court rules. Gotta sink the last one.
That hurt.
It never touched you.
Right.
And it's not solid. This ball is mostly empty.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale, in the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty.
Most people think that the vacuum is empty. But for internal self-consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
Organizations like NASA, British Aerospace, are all trying to tap into this incredible, unimaginably large energy sea. And they feel if they can tap this, we can travel to different galaxies. So they understand that in empty space, there is this unbelievable energy.
The major basic idea that quantum physics implies, which makes us understand this or even think about this new paradigm, the thing which is that there's this underground, there's got to be a realm of existence which cannot be ever touched on or seen, which bubbles into the existence giving rise to our understanding of the world.
The tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life? At the basis of it all, life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, pure abstract being, pure abstract self-aware consciousness, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
What makes up things are not more things, but what makes up things are ideas, concepts, information.